what concepts our student, the model, has learned. Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis.
Oh, one thing is, can you enable screen sharing, please? Great, thank you so much, and welcome everyone. I apologize a little bit for the delay, the realities of virtual conferencing. Welcome to the first workshop on visualization psychology. I am really excited to have you all here, to have a really fun program ahead. We're gonna have one keynote talk to open up with Barbara Tversky, which I'm going to go through this intro pretty quick so we can get straight to that. And then we will have 3 paper sessions and wrap with a discussion of next steps. The objectives for our workshop are essentially to figure out what are the opportunities for innovation at the intersection of the fields of visualization and psychology. And the specific goals in this investigation include everything from broadening the scope of empirical work to understanding how we might co-develop theories and knowledge, to identifying how VIS might offer key questions for psychologists, and to generally foster a community of researchers interested in this intersection. And when we think about visualization psychology, one thing I want to make clear as scaffolding for the discussions that are about to ensue is that we conventionally think of the relationship between visualization and psychology as that between perception, with initiatives like Believe Yesterday, work in eye tracking and vision science that started to become part of the community. And we often see ideas from cognition also influencing visualization research. But there is a wide variety of elements ranging from sports psychology, health psychology, clinical psychology, educational psychology, all sorts of aspects and subdisciplines within psychology that may benefit and be benefited by visualization. And we're hoping that this workshop will offer us a platform for beginning some of these discussions and understanding how do we broaden knowledge in this community for mutual benefits. I would like to just give a brief shout out to the co-organizers of this workshop, as well as the members of our advisory board and program committee who made this a possibility. And just give you a quick high level of what the workshop structure will look like today. So we will open with our keynote, where we are excited to have Dr. Barbara Tversky joining on. After the keynote, we will have a paper session, a break, and then our final 2 paper sessions. Each paper session will consist of 1 talk followed by 2 minutes of Q&A. And then at the end of the 3 talks for the session, we will have 15 minutes for a summary panel and discussion. So hold on to your broader questions about advancing this intersection for those panel discussions. I think it should be a lively conversation, and I encourage you also to join in the Twitter or Discord channel as ways of joining us today in the course of that conversation. With that, I would like to hand it over to Darren Edwards, who is one of our co-chairs, who is going to introduce our keynote speaker. Darren?
Hi, can you hear me? So we are very lucky to have a very eminent psychologist with us today, delivering this keynote speech for our very first visualization psychology workshop, hopefully the first of many to come. Professor Barbara Tversky studied cognitive psychology at the University of Michigan and has held faculty positions at Hebrew University, Stanford University, where she's Emeritus Professor of Psychology, and Columbia Teachers College. She has enjoyed collaborations with linguists, neuroscientists, philosophers, and computer scientists. Her research has spanned memory, categorization, also my area of categorization, language, event perception, spatial thinking, external mind, gesture, and creativity, some of which has been brought together in a recent book, Mind in Motion, How Action Shapes Thought. Barbara was also president of the Association for Psychological Science and elected to American Academy of Arts and Science and the Society of Experimental Psychology, and a fellow of the Association for Psychological Science. and the Cognitive Science Society. So a lot of ands there, and a great history. So without further ado, we're losing a bit of time, so I'll pass it straight over to Barbara for her keynote speech. Thank you very much. Barbara needs a microphone. Can someone unmute Barbara?
Okay. Thank you so much for that kind introduction. I'm really honored to be here and to be speaking here. I apologize for the various difficulties of getting on. And I'm going to present you today with little bits of many things. I've lived a long time and done a lot, and hope that some of these will inspire some ideas or resistance in the rest of you. As I say, I'm honored to be here. So the mind is too small. When thoughts overwhelm the mind puts thought into the world. And the mind puts thought into the world in many ways, in words, as I'm doing now, in gestures and in graphics. And I'll primarily talk about the latter two, which are related and distinctive in the sense that their relations to meaning are far more direct than words, which have only symbolic relation to meaning. So all of these are cognitive tools. They augment thought of our own, and they communicate thought to others. They expand the mind by offloading memory and information processing. Graphics and gesture use space to represent literal and metaphoric space and action. They promote comprehension, inference, discovery, creation, collaboration. And I'd like to say, with some caveats, that they're uniquely human. I mean, bees dances are, and animals do gesture, but not to the same extent that we do. And we've never seen a bonobo sketch a map in the sand to tell another bonobo where to find something. So I'd like to open with gesture. Again, I think it's related to visualizations. I got from one to the other. And I'm going to show you a person alone in a room. She's reading this description, which is of a small town. It goes on much longer. There are 8 landmarks that need to be located and remembered, and she's going to be tested on it. So you won't be tested. You don't have to read it. I want you to watch her while she's reading. So what she's doing, in case you're having trouble seeing, is she's reading intently. She's not looking at her hands. She's sketching a map, essentially, of what she's reading. So, and she's repeating it as she reads and rereads. The lines are paths. The dots where she's poking her finger on the desk are locations of landmarks. When she does this, we've tested hundreds of people by now, she remembers better. If we take another group, make them sit on their hands, they remember much worse. So and some of them say, I can't think without my hands. So what we think that the hands are doing is translating the words, which are quite hard, into a spatial model of what she's reading, and that the hands actually help her create the model in the mind that she will use when she answers questions. So by now we've tried many other examples of this. I'll show you one more person. She's learning a schedule. You can see that she's putting things into a matrix, which is essentially time by activity. She's got a number of activities that she needs to remember. She is looking at her hands, I think, to calibrate this large table that she's essentially got the scaffolding for on her desk. So again, about 70% of our informants, our participants, do this and do that kind of gesturing. Some don't, it isn't everybody. When they do it, they remember better. We've also found, as have many people found, that when I make gestures, you remember better. And that again, my gestures, especially for things like maps, mechanical systems, visualizations of data, higher, lower, that my gestures also model the situation that I want you to remember or understand that I'm trying to get across. Those gestures that I make when I'm speaking to you probably help my thinking as much as they help your thinking. Bob Krause years ago did studies where people sat on their hands, they couldn't find words. So the gestures help at many different levels for articulating, for clarifying and articulating thought. So spatial thinking, it's using actions in space to think and to communicate, essentially using marks and place in space to think and communicate. And my argument is that it's faster and more direct than arbitrary words. So great stories are timeless. This was a year ago in New York when you could still go to movies. This was a poster on all the bus stops. So people have been putting their minds into space for millennia, probably 70, 80, 100,000 years. This is the oldest map known. It's about 2 inches by 1 inch. It was found in a cave. In Spain. It shows the environment around the cave. This is the previous oldest map. Another map. Time is also present in ancient visualizations. This is a stampede, quite common in petroglyphs and caves. This one from Chauvet, 35,000 years ago. This one is an explanation. It's how to make bread, from sowing the wheat to baking it and grinding it and baking it. It's in an Egyptian tomb. You can see it as soon as you can travel. A journey of an emperor in a Chinese scroll. Number, another concept that's ancient. This one is rather mysterious. It was found on stone, bones. 70 to 80,000 to 100,000 years ago. So I'm going to skip this and go to here because I'm already behind. So what are graphics made of? They use place in space and marks in space to create meaning. Place in space, we know vertical, that on the whole, you fight, in order to grow up, you fight gravity. So up is more, it's good, it's powerful. Your piles of money grow. If you can build tall buildings, you must be strong and rich. So vertical is loaded. The horizontal, less so, because there are no natural asymmetries in the world or the body on horizontal. Reading order, a cultural artifact, does highly affect the horizontal. And cultures that read from left to right, left is primary, better, so forth. Then there are marks in space. I'll talk a little bit more about that. So our marks in space can be iconic. They can resemble what they represent. They can be figurative, as in scales of justice. They can be symbolic, as in the word justice or the symbol plus or equals, or they can be schematic, like a dot. These are the ones that interest me because they're with icons, the components of graphics, of visualizations. So points on the whole represent places and ideas in networks, for example. Lines represent paths or relationships in the world or in a network. An arrow is an asymmetric path. A circle or a square or a blob can be a set or an area. Again, we have parallels in gesture. And we've created a program, Psychology of Visualizations, of empirical semantics, where people interpret a graphic and another group creates a graphic from an interpretation. And if we get the same thing back, we know that we have meaning that is shared by a community. So an old study, we asked people to interpret bar graphs or line graphs. We found that that boxes contain and separate, so they should yield discrete comparisons. Lines connect, they indicate a trend that A and B are on the same dimension, have different values. And sure enough, we get trend descriptions for the lines, discrete comparisons for the boxes, and we get the reverse when we give the interpretations and ask for a visualization. Mechanical descriptions, we gave people diagrams of a car brake, a bike pump, a pulley system with or without arrows. When we had arrows, people gave us functional, causal, temporal descriptions of the process. Without arrows, they told us where the parts were in relationship to each other. So the arrows changed the meaning enormously. And we found, again, the opposite, that if we gave people structural descriptions, we got diagrams like on the left, labeled parts. If we gave people functional descriptions, they gave us arrows always, and a step-by-step interpretation of the process. So again, arrows have meaning, lines have meaning, dots have meaning. We've done a series of experiments like this, showing the meaning of these graphical forms. This someone sent me. It's an aerial photograph. There was a police helicopter chasing a car thief, and the people who had witnessed it got on the ground and made themselves into an arrow for the helicopter pilot to see. So we've instituted a program called the 3 Ps for creating effective graphics. The 3 Ps are producing. One group produces graphics. Another group rates their preference for different kinds of graphics. A third group uses the good ones and the bad ones by production and preference in performance. Again, if all 3 of these align, you have a good graphic. It's a way of empirically creating good graphics. We have many examples. I can't show you all of them. There's an interesting disparity on one of them, namely cycles. It's a longer story, and I'll tell it another time. but it worked with sketch maps. This was work done with Manish Agrawala and Chris Tolte years ago on finding what the cognitive design principles are for sketch maps. They seem to be points and lines connecting. Distance and direction aren't as important. They can be quite inaccurate, and both in what people produce and in what you give them verbally. And on the whole, the context disambiguates. So if you draw a right angle turn, but the turn is really not 90 degrees, it's 80 or 120, you're going to go the way the road goes, not the way, not 90, make your own road. It worked for assembly instructions. We want step by step using 3D perspective and arrows and guidelines. So again, cognitive design principles. Another area we've gone into that I think is really quite important in visualizations, and that's what are the inferences people are making. If you look even at a simple graphic of a histogram or a line graph, you're making tons of inferences from it. You can look at it. That's what Simon and Larkin wrote years ago about the value of graphics, is that they enable huge numbers of inferences. And a lot of the research tends to look at just one inference and is it better or faster with one kind of graphic or another. And because graphics are used, information graphics, even Sci-Vis, are used for so many inferences, looking at what the inferences people make seems to be important. So we've looked at plotting where people are at different places and different times, either in matrix-like things or in these pseudo line graphs. And we find that when we use lines, people make more inferences about temporal sequence, which may be what you want to get across, so that encourages lines. When we have dots as in the left, people make more inferences about everything. So they'll even give you personality things. Somebody goes to the gym, they must be a jock. They go to a gym with another person, they must be the friend. So people are making broad and wide different inferences when you give them this graph that isn't emphasizing any of the variables over another. So those are important things to know when you're creating visualizations. What are people going to infer? What are they going to miss? I have a colleague in chemistry who loves animations of molecules. But what he tells me after people have seen his animations is the white balls, which are oxygen, are pushing the red balls to get together. Now, I don't know if that's the inference you want to make in chemistry. Okay, sometimes you want ambiguous visualizations or graphics, and the ambiguity, this is an architect's sketch, allows reinterpretation. And in many cases, that's important. You want to reconfigure. You have a messy scatter plot. You want to look for what's happening, and you want it to reconfigure so that you can discover more things. Artists use this productively on purpose. They say the ambiguity allows them to explore and make discoveries as they draw. So another use of visualizations is in learning. And years ago, Eliza Bobick and I did a study. She was teaching chemical bonding to bright junior high students. And she took advantage of that class and several others to test whether creating a verbal explanation of the processes, as is normally done on tests and papers, is better than creating a visual explanation. So she taught chemical bonding several days using all the usual devices. She tested the students, and then she divided the groups in half. Half were asked to make a verbal explanation, half were asked to make a visual explanation. They had no access to textbooks. They had to do it from their minds. And then there was a second test afterward. Both groups improved just from making the explanation, but those making the visual explanation improved far more. So here are the data. Before the explanation, they're equal in the test. After the explanation, both groups improved quite a bit. That's important. But the visual group is much more. They were better both on process and on structure. Eliza was able to code all the answers on the test. Here are some of their visualizations. You can see they aren't what they were taught. They have sharks grabbing electrons. They have people giving electrons, a little more peaceful, boiling pots. So these visualizations, these visual explanations came from their heads. They weren't what they had seen. And again, the people with the visual explanations did better. We think it's because there's a natural association between the visual spatial and the concepts. And it gives you, so there's that natural explanation. There's a check for coherence. Do the parts fit together? There's a check for completeness. Do you have everything there? So we think there are many reasons why those are the three key reasons why the visual explanations are so much more effective than the verbal. So visual narratives. Here I'm going to jump into comics really quickly. I'm not keeping track of time, unfortunately, but so visual narratives. We often want graphics such as you see in newspapers now showing data stories with data, and these seem to be more and more important, both online and in print. So they need to break up time and space. They need to show time, space, action, causality, emotion. They need to connect sections, visual and aphora. And the secret ingredient, I'm going to use examples from comics, which do this artfully, are figures of depiction. So pun, irony, metaphor. I'll show you some. I want to also, before I go into this, introduce a caveat. We've started looking at cultural differences in visualizations of many kinds, comics, kids' books, math diagrams, and so forth. And on the whole, we're finding them. I have a number of Chinese and Korean and Japanese students, so they can look at the websites in those languages. And for the most part, we're finding that Eastern visualizations in comics, kids' book covers, diagrams, show more action. And this fits with the concept of Eastern communities as being more connected socially. And Eastern math diagrams are more complex, which again fits with the idea that their environments are more complex, and this has been ascertained in research. The Western more individual. So this, I think, is an important direction that Viz Psych could take on in a nice way, and where images on websites provide us with data. So visual and aphora in telling stories. This is a New Yorker cover. It's about publishing a book, from writing it to it ends up on the streets warming the homeless, being burned. It's called Shelf Life. So it's a pun in that way too. And what provides connection between all of these frames is this red book. And it's a kind of visual and aphora going back and connecting over time and space. You can do it also in these nice splash sheets that are quite common in comics, where you have the entire space there, and then the frames give you the temporal story superimposed on this space. Metaphors and puns. Here's a metaphor from the turn of the last century of the business world being a rat race, and parts of Second Avenue still look that way, and there still is a rat race. This was the New Yorker cover after Obama run, and you can see it's the Lincoln Memorial. It's got the O of New Yorker being both a moon and Obama. So you have polysemy, metaphor, all of these lovely things that visual graphics of data and so forth could use. Onomatopoeia, rhythm, a fast chase. You've got it, the frames are suddenly on the diagonal. This one I love, it's little Sammy sneezes and he going, chew. And when he goes chew, the frame breaks. So I'm going to skip, not show you all of these, just leave you so I can get closer to the end. So all creatures must move and act in space in order to survive. Even grass needs to move toward the sun, away from the wind. Without movement, there's no life. So all thought begins as spatial thought. Spatial thought is back there with amoeba, one-celled animals. Viruses move in space. They have to Earth in order to infect us. And so motion, space and motion is there in the simplest of organisms that are alive. So space is special. I'm going to again skip that. So some of the basis in humans for spatial foundation of thought is in the work that won the Nobel Prize and the Mosher and working in John O'Keefe's lab. So the three of them won it. Many more people were involved. So there are single cells in hippocampus that fire for specific places. Next door, one synapse away, are grid cells that map them spatially. It turns out that these single cells in hippocampus in humans fire for events, people, and ideas. They gather information from all over the cortex, information about touch, sound, sight, kinesthetic feedback, all of that in one neuron in the hippocampus. So it's representing a rich complex of sensations. And those the place cells get mapped in grid cells in temporal, social, and conceptual relations. So this is new work in humans. So the same brain structures that represent places and spatial relations represent events, people, and ideas in temporal, social, and conceptual relations. So that seems to cinch the case that spatial thinking is the foundation of thought. The metaphor I use is that the hippocampus forms checkers for ideas, and the grid cells is like a checkerboard for relations among ideas. So our feet go from place to place along paths, just as our minds go from thought to thought along relations, and our hands act on things just as our mind acts on ideas. So we raise ideas, we toss them out, we throw them together, we tear them apart. There's almost no way to talk about ideas except using the language that we use on objects. And then we turn those into gestures. We toss out ideas, we tear them up. Those get turned into gestures that again act on thought and facilitate our own thought and thought of others. So these appear in designing the world. This is the world as nature gave us, not the concrete, but the leaves. And this is the world that people design. So people create themes. Our rooms represent different themes. They collect different objects for the same function. The kitchen is for cooking, the dining room for eating, the bed for sleeping, the bathroom for cleaning, many different objects combined for the same purpose. We also create categories on our bookshelves, in our supermarkets, in our kitchens, and we have categories there and orders on our bookshelves and hierarchies. So we have all the bowls on one shelf ordered by size or arranged by size. So we have categories and hierarchies. We have them repetitions, symmetries, embeddings, one-to-one correspondences in our buildings, in our table settings. Look how much intelligence there is in the world that babies can capitalize on that wasn't there when we were wandering from cave to cave. We turn those organizations into visual graphics and into periodic tables, timetables, bar graphs. So this is the likelihood of a computer issue being solved by the big bar, turning it on and off again, the little bar, reconfiguring, reimagining, antivirus software, uninstalling, etc. So we not only design the world that reflects the design of our minds, the categories and orders and so forth in our mind, we diagram the world. The world is one vast visualization seen from the air. So on airports, remember airports? They depend on that, so that the buses go one way, the service cars another, the planes another. It prevents accidents. Similarly, our roads now are filled with directions on them, special lanes for bicycles and buses, for parking, for turning left, for turning right, for walking. Our behavior is controlled by this diagram in the world. Is both facilitated by and controlled by. All those things have advantages and disadvantages. So the world is a diagram, design spaces that are created by actions and enable abstractions. And it's a term that I've coined called spraction, which is actions in space create abstractions. And again, they get those actions in space design the world. They get turned into gestures that for thinking about the world and communicating about the world, and they get turned into visualizations that we use and design to communicate about the world. So thank you to the funding organizations and to you for listening patiently to that super speed presentation.
Okay, thank you so much for that, Barbara. That was a very, very interesting talk. We've had a huge amount of activity on our chat platform with questions. We've only got about 5-10 minutes to go through them, so I'm hoping to get through as many as possible. I'll quickly just reel them off and maybe we can get a few quick answers. Very first question here says, asks, do you think the gestures created by interacting with visualization may also support memory and comprehension?
So that's a really interesting question. And it worried us that, you know, if there is a theory of gesture that say that gestures create visual representations. So we thought if we give the visual representation, will people not gesture? Well, it turns out they gesture exactly the same. So we made visual explanations of various things that we'd had, of maps, of mechanical diagrams, of a whole variety of things. And one group got the verbal and we looked at the gestures and they happened as I told you. The other group got the visual, the diagrams themselves of a bicycle pump or a car brake or a map of these environments. And the people, in order, they had to learn them again for a test. And when they were learning, they were gesturing the same way that they would have gestured the same way that people who had the verbal explanations gestured. So again, they were using the gestures to understand what they were seeing and to make a representation of it in their minds. So that was super interesting to us. You don't see that in conversation. You have to put people alone in a room, because there's something, if I'm gesturing while you're speaking in order to understand you, it's as if I'm taking the stage, as if I'm interrupting, because gestures are much a part of communication as language is. So I can't gesture listening to, except if I'm doing it sort of surreptitiously in small ones in my lap, and people do that sometimes. But in order to see these gestures, it's easier to make people be alone. Anyway, thanks for the question.
Second question we have here is, do different gestures have different effects on enhancing memory? So what's the relationship between gestures and the enhancement of memory?
So that's again a study I didn't have time to tell you about. It's amongst the many studies that we've done using gestures to teach. So we taught how a car engine, either with gestures that showed structure, like the shape of a carburetor or the shape of a piston, or gestures that showed action. And then we had them create a verbal explanation, a visual explanation, and they took a test. Our hypothesis was that gestures are actions, so they should be especially good for creating action, for instilling action. And action is hard for people to get. We know that from other studies. You need to be high spatial to understand action from language. You can be low spatial and really smart. So it's somewhat independent. And we did in fact find that these action gestures had a huge effect. They did better on the test, but they also, their visual explanations used far more action. So they showed bubbles for the mixture of gas and oxygen in the carburetor, and they showed arrows. They used huge numbers of arrows just from seeing the gestures that showed action. They also used more action words, even though the verbal explanation was the same. So seeing those action gestures had a deep effect in their understanding of action. Another study we did was on cycles. So it turns out if you give people verbal descriptions of cycles and ask them to put something down on paper, they make lines. Even when you say start with a seed and end with a seed, they make a line. Most people, 80%. So we found if we said you start with a seed grows, a flower grows, it gets pollinated, and then there's another seed. If you make a circle and ask people to draw, they do draw cycles. They do draw circles. So our gestures changed the way they were thinking. And we were worried that was just, they were drawing a circle because they saw a circle. So instead of having them draw what the cycle represented, instead we had them say, what comes next? And the people that had seen a cycle went back to the seed and the flower grows and gets pollinated. The people that had seen the circle. People that had seen the line said, I gather the flowers for my girlfriend. So they went on to another temporal step. They didn't go back to the beginning. So making the circle changed their thinking as opposed to making a line. So yes, gestures can have deep effects on and you know, there are subtle things, not just gestures, that we pick up on people. If people look aside, we look where they're looking. They're not attending to us. So they're hugely powerful, and I think in ways that we're not explicitly aware of. And the trouble with starting to study gesture is you start looking at people's gestures and their body language and pay less attention to their words. But it's really quite insightful to do that, right? Babies, another whole area where gestures are hugely important. Thank you. I'm answering long to short questions.
Those are very thorough. Thanks for that, Barbara. There's another one here. I think it's very, very related. Someone mentions a Kevin Lynch study on people, on how people imagine the city, and they generally remember the city through similar symbols of points as landscapes, lines as edges, and also as regions. Does actual experience of space or movement in it serve a similar cognitive function to gestures in our memory of space?
Yeah, no, that's exactly the point I wanted to make, really, is that they are quite similar. And there have been studies where we've asked people to understand something and either make gestures or make diagrams, and they're quite similar. So they're in both cases using marks in space, whether they're actions of your hands placed in space, and space to convey meaning or to create meaning. So I think there are huge similarities. Gestures disappear. They seem to be especially good for action. And we know that on visualizations, actions can be problematic, animations can be problematic to perceive and understand without without very creatively produced animations. So they may be more helpful for one thing than for another. There have been a couple of studies on people explaining visualizations the way we explain, if I had a PowerPoint behind me, I'd be pointing to it and gesturing on it. And that combination is really very good. We've done a study with people collaborating on finding a route on a map. If they're together and can gesture on the map, the communication is more pleasant, faster, more reliable, more accurate, and the routes that they create are better on the whole. So that combination of having a workspace where you can lay out your ideas together and then gesture on it is much better than either alone. They complement each other in good ways. They disambiguate language. So it's disturbing that Zoom doesn't allow that easily. I think any of you who teach become and certainly anyone who uses visualization gets very reliant on the role of the gestures on them in conveying and understanding and collaborating.
Okay, excellent question here by someone. Have there been any studies on the visually impaired in regards to this? Do these individuals still activate the same brain cell patterns or think visually in their minds as well?
Yeah, these questions are great. So we haven't looked at that, but Susan Golden Meadow, who wrote a beautiful book on gestures a number of years ago, almost 10 now, and has done beautiful work. She publishes faster than anyone can read, and does great work on gesture, on home sign. So she's looked at with Jenna, why can't I remember her last name, who's at Indiana. They looked at blind children, and blind children gesture. So blind may have and often do have excellent spatial understanding. Len Talmy, whose work many of you may know on language, is blind. He's incredible in finding space. He draws on the blackboard. He was one-sided, so he has that advantage. But Susan Golden Meadow and Jana were looking at children born blind. They gesture. They don't know that their gestures communicate to others. So their gestures must be helping their own thinking. And this is quite common in blind. They think spatially. In fact, maybe they need to think spatially better than we do because we have vision to rely on. So they can become very adept. I once had an almost completely blind undergraduate. I was teaching learning curves. And of course, she couldn't see the blackboard then. This is years ago. And she came after class and I sat next to her and I took her hand and I said, this is time, this is performance, and this is a learning curve. I just moved her hand and a light bulb went off. She got it like that. So we do often do a disservice to blind by not realizing that they think spatially, and our infographics and sci-viz and all of that is spatial, and it's another channel that should be made available to them. So and people do have tactile maps and diagrams. There's a bit of a problem there in that our fingers are really designed to get texture and temperature and weight and things like that, and not designed as our eyes are to get objects and lines, which our eyes are designed to get. So it translating the visual to the tactile can be complicated. It can work though.
Okay, Barbara, thanks for all of that. That's really, really great. If you do have time to engage in our Discord app, there's loads of more questions there. And the guys in the community would really love to ask you some more questions. Unfortunately, we're out of time and we've got to move on to the next planned sessions. So thank you, Barbara.
Thank you. Thank you so much. This was a pleasure. Yeah.
Cheers now.
Wonderful. Yes, many thanks for a really exciting talk. I think it's inspired a lot of people to be thinking and digging into the work you mentioned. So I'm looking forward to seeing what's going to come out of some of these conversations. For our first paper session, we're going to be talking about papers on the theme of cognition and metacognition. So building very nicely off of a lot of the work that Barbara just presented. It's my pleasure to introduce our first speaker, Ryan Wesslen, who's going to be talking about using resource rational analysis to understand cognitive biases in interactive data visualization. So without further delay, here is Ryan.
Hi. My name is Ryan Wesslen, and my talk is on using resource rationale analysis to understand cognitive biases in interactive data visualization. And this is joint work along with my co-authors, Doug Markant, Alireza Karduni, and Wenwen. So traditionally, cognitive biases are defined as systematic errors in decision-making. Recently, there's been an interest in the VIS community on whether we can find evidence that such cognitive biases transfer to decision-making with data visualizations. And the hope of identifying such biases is that by doing so, we can also find ways data visualization techniques like interaction or different data representations can mitigate such biases as well. But such research has raised several challenges to studying cognitive bias in VIS research. First, we don't have a definitive conclusion of what bias behavior looks like. The problem is many notions of cognitive biases do not provide sufficient theory to provide mathematical predictions of rational behavior as a comparison to empirical studies to find systematic deviations of it. Second, while VIS research has produced multiple empirical studies and framework papers on cognitive biases, there still lacks a unified framework of cognitive biases, especially across different cognitive biases and in data visualization that provide testable predictions for empirical research. And last, several VIS cognitive bias papers rely on notions that cognitive biases are systematic errors due to an over-reliance on heuristics, and these interpretations overlook notions by Gigerenzer on why heuristics tend to reasonably work effectively, which beg the question, what if such biases are really rational? And so to unify these concerns, we argue that the idea of resource rationality introduced by Griffiths, Leder, and Goodman combines three solutions, Bayesian cognitive modeling, Mars level of analysis, and limited cognitive resources, into a unified framework that can help the data visualization community reinterpret many cognitive biases instead as rational for optimizing agents that are bounded by their computational resources like time or memory. And to understand resource rationality, let's consider Mars's three levels of analysis, specifically the top two levels. So at the top, we have the computational level, which is used to describe and specify the problems we are faced with in a generic manner, but do not say how these problems are to be solved. Next, we have the algorithmic level, which forms a bridge between the computational and implementation levels, describing how the identified computational problems can be solved. It's here that Bayesian and machine learning methods find their place. And the key idea of resource rationality is to push the principle of optimality in the computational level one level deeper to the choice of what computations to perform in that algorithmic level. Said differently, the problem isn't just optimizing the abstract problem, but instead for the agent to choose the best algorithm to take given the trade-offs of computational costs. And so if we start at the computational level with the optimal solution, we can assume unbounded rationality. And as we can move closer to the algorithmic level by imposing constraints on resources, for example, time or memory, that provide a slightly more realistic computational architecture for the agent. And through the principles of resource rationality, this enables predictions that can be tested using a more realistic process model. And future studies can then iterate by formulating additional resource constraints. And so what makes resource rationality very powerful is that it has the potential of reinterpreting many cognitive biases like availability, or what we'll consider anchoring and adjustment bias. So for intuition, consider these two questions. What is the freezing point of vodka in Fahrenheit? And how long is Mars's orbit around the sun in Earth days? And for each of these questions, unless you know lots about science, you'll likely solve them by using a familiar reference point or anchor, and your answer is probably systematically different than the true answer. And if you're like most people, your answer for the freezing point of vodka was too high. The true is negative 17 degrees Fahrenheit. And Mars's orbit was too low, 687 days. And the problem with each is that in the absence of knowing the exact answer, you'll likely use a familiar reference point, namely the freezing point of water at 32 degrees Fahrenheit, or the number of days in an Earth year of 365 degrees. So the crux of the classical anchoring and adjustment bias is that people answer starting with a familiar example, an anchor, and fail to sufficiently adjust away from this, leading to a systematic bias from the actual answer itself. And so to test their theory, Leader and et al.'s 2018 paper developed two mechanical Turk studies focusing on bus departure times. Participants were given information about when the passenger had arrived at the bus stop, the blue line in the gray box, and on the bus's timetables, the two orange lines, and asked to predict when the passenger would get on the bus by clicking in the gray box as indicated by the green line. And the experiments included a 2x2 within subject design in which time and error costs varied. And when participants were incentivized to respond quickly, that is, had a non-zero time cost, a falling red bar indicated the passage of time and its costs. And interestingly, predicting bus wait times have also already been studied in VIS by Kay et al. 2016 and Fernandez et al. 2018, but in their case using different uncertainty representations. And so using resource rationality, these studies assume that the individual uses an MCMC through Metropolis Hastings algorithm as an approximation for the decision of the time the individual would be picked up by the bus. In this algorithm, we assume individuals start with initial value, that is an anchor, and stochastically accept or reject adjustments to try to get to the true answer. Resource rationality question is ultimately at how many adjustments are needed before stopping. And under the classical notions of anchoring, we can view the adjustment stop well before reaching the true answer and therefore deem such behavior as biased. However, the resource rationale interpretation of anchoring as an optimal trade-off between the cost of error and judgment and the cost of time it takes to reduce this error. And this hypothesis has been formalized by a computational model that chooses the number of adjustments in the MCMC process that minimizes the expected sum of the time costs and error costs. In using resource rationality, this framework predicts that an upper bound of anchoring bias, as shown in the bottom right, as it increases linearly with the distance of the anchor from the correct value. And this prediction leads to a linear regression model that can be compared against empirical results. And in regards to time and error costs, this model also predicts that the adjustment should decrease with the time cost, but increase with error costs, regardless of whether the anchor was provided or self-generated, which are tested in Study 1 and Study 2 respectively in these experiments. What the authors found is that people appeared to rationally adapt their number of adjustments to the cost of time and error. And when errors were costly, people invested more time and were more accurate, their adjustments were larger and observed less evidence of anchoring bias. So to conclude, there's lots of opportunities for resource rationality in VIS research. First, VIS research already provides a wealth of techniques like advances in uncertainty representation, innovative applications in Bayesian cognitive modeling, and techniques in belief elicitation that could make for a rich playground for resource rationality. Second, given our focus towards Mars's algorithmic level, we think there's opportunities for future work to explore for links with many different machine learning algorithms to better understand machine learning explainability when there's a large divergence between what the same model predicts versus how a person interprets the model's outputs. And last, resource rationality works best in applications where sampling occurs through repeated trials, which VIS research have a lot of experience with such applications. This could include hurricane prediction, decisions on daily health outcomes, or what our team is looking at, financial allocation decisions for long-term investments like retirement. So this concludes my talk. Thank you for your time, and I'm now happy to answer your questions.
Don't worry about introductions. Let's roll the videos and then I'll tackle the introductions in the panel. Yep, let's try and make up a little bit of the time and we'll do introductions at the panel level. Thank you.
Hi, Good morning, and thank you for attending this presentation. What I will be introducing today are viewpoints developed in collaboration with my colleague, Dr. Darren Edwards. So the focus of this talk will be on the development of visualization psychology analysis tools to account for trust. The concepts of trust and trustworthiness have recently gained much attention due to the advent of artificial intelligence and the growing traction gained by autonomous systems in all aspects of life. Trust is behind acceptance and adoption, which are fundamental elements in the success of a system. And when we look at autonomous systems, their acceptance and adoption can have beneficial effects on people's lives. To this extent, efforts have been made to develop frameworks and tools to understand and support creation and establishment of trust. One of these being leveraging explainability as a means to support understanding. And in the context of explainability, visualization is playing a pivotal role. Nevertheless, trust is a complex entity with many implicants and implicants, social, legal, ethical, cultural, and so on. To define the building blocks of trust and trustworthiness still remains an open challenge. And in the context of visualization, we can easily identify three major questions. What makes a visualization trustworthy? How can we design to support trust, but also, given the multifaceted nature of trust, can we perhaps design to understand trust itself? Trust pertains to human factors, and visualization research has given human factors a forefront role. To this extent, it has leveraged tools provided by different branches of psychology and social sciences. These can be the providers of important theoretical frameworks to support the creation of foundations needed to answer visualization questions pertaining to trust, such as the one we just mentioned: what makes a visualization trustworthy, and how can we design to support trust? The third open question, can we design to understand trust itself, however, raises a further interesting point. So when looking at trust dynamics, for example, psychology requires tools as much as visualization does. In this context, visualization can actually help. A straightforward example is network science. Given the hierarchical and graph-based nature of intelligence workflows, network visualization is a promising area to help the understanding of the contextual network and important features of trust. This can be achieved by plotting the relationship between individuals, community groups such as peers, media, online influences, cultural influences, and so on. Also by supporting the mapping of important constructs that make up a trust network for a particular individual or a community. And also providing metrics to achieve concrete measurements or summative results, which enrich and are enriched by the corresponding visual encoding, such as a node link diagram. A further example can be ELM diagrams. With ELM, we refer to the elaboration likelihood model, which in psychology is a dual process theory employed to describe the change of attitudes. The model suggests that users elaborate information deeply to help them decide whether the object, the person, or activity should be judged as trustworthy. ELM relies on the definition of two routes to persuasion, one central and one peripheral. Different stressing factors define the choice between either one of the routes. Other equally important factors are user experience, which can increase trust if it is positive, credibility of information, self-calibrated degree of confidence. ELM diagrams are employed to depict the routes of persuasion. And given its workflow-based structure, an ELM diagram can therefore easily be converted to a dynamic weighted graphs with multiple layers of encoded information. Network visualization is not the only example of interesting visualization tools. Other areas can be explored, and these include and are not limited to, for example, visualization for agent-based simulations, which allow to model social behaviors and norms. So there is indeed a possibility where both disciplines can mutually benefit each other to address the challenge of trust. So visualization has been a recipient of research results from psychology, and in that psychology can help define visualization-supported metrics to identify trust enablers, their interconnections and influence. Visualization has also matured to a level to bring its own contributions. When the problem domain increases, visualization tools may be usefully applied to explore and inspect multi-layered information within, for example, the same layout. So to conclude, there may be a need to formalize this relationship. And in this context, visualization psychology draws schools of thought from both subject areas, that is, psychology and visualization. So it could very likely act as a container for the formalization of expertise and knowledge which are acquired through the synergy of these two disciplines. Furthermore, in the specific and pressing context of trust, it can propose models and tools that can be usefully applied to formalize an answer. Of course, greater ontological accounting of these approaches in the various domains may be required to be able to substantiate the methodological need for this approach. But we also have to consider the possibility that there may also be further synergies not yet explored. This concludes my talks. Thank you very much.
Hi, my name is Melanie Bancilhon, and today I'll be talking about the evaluation of decision-making with visualization. Researchers have evaluated the impact of visualization on decision-making in a number of ways. In the medical field, Galezic et al. Interrogated participants about the perceived seriousness of a disease and the helpfulness of screening after showing them information using either icon arrays or text. In the visualization field, researchers have measured different decisions made from visualizations using simulations. Grace et al. Has used the Facebook game FarmSmart to observe how participants best grow and sell crops given uncertainty weather information. Kay et al. Has observed people's ability to leave their house on time to catch the bus while minimizing waiting time at the bus stop. Bus data was shown in the form of different uncertainty visualizations. Looking at these three examples from prior work on decision-making with visualization, we see that the decisions differ in nature and the visualizations are all different. A lot still remains unknown, and there lacks a unifying framework to evaluate the impact of visualization on decision-making. Other communities have investigated risk behavior and decision-making processes and provide methods for quantifying and modeling decisions across different scenarios. For example, economic theory provides a framework to evaluate decisions under risk. In our prior work, we leveraged principles from prospect theory to evaluate the impact of visualization on decisions under risk using a large-scale lottery game. If you'd like to know more about our method, please attend our InfoVis talk, Let's Gamble, How a Poor Visualization Can Influence Risk Behavior. For this talk, we're focusing on how dual process theory, widely recognized as the main mechanism behind decision-making processes, has evaluated decisions. Dual process theory posits that there are two types of reasonings that operate in parallel, type 1 and type 2. Type 1 reasoning, also referred to as just reasoning, is at the forefront of decision-making processes and is guided by intuition. Type 2 reasoning is responsible for quantitative and logical operations. Let's look at an example of how we can identify type 1 and type 2 reasoning with visual information. This graph shows the population growth of species X over time with the introduction of a predator species. At first glance, it may appear that when the predator species was introduced, the population of species X dropped. With some effort, you can mentally reorder the values on the y-axis to match your mental schema, and then you may notice that the introduction of the predator species actually correlates with growth in the population of species X. Cognitive fit theory suggests that the user compares a learned graphic convention to the visual depiction. Visualizations that do not match the mental schema require cognitive transformations to make the visualization and mental representation align. Here's an example of how someone might make a decision using type 1 or type 2 reasoning. Consider the following question. Is the average of the two bars A and B closer to 2 or 2.2? Under type 1 reasoning, the viewer would make an inferential process based on their mental schema of the bar chart and visually estimate the average is closer to 2. Under type 2 reasoning, the viewer uses significant working memory to identify the values of A and B and computes the average to be closer to 2.2. There are a number of cases where it has been shown that people default to just reasoning when making judgments and decisions. Rita et al. Has shown that experts in the medical field tend to engage more in gist-based decision-making compared to novices. They also showed that with development, children tend to use more gist-based reasoning. Lloyd et al. Has shown that patients tend to gist more on surgery day compared to diagnosis day when asked about the risk of surgery. Now consider the following question. A bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? More than 50% of students at Harvard, Princeton, and MIT routinely gave the incorrect answer, insisting the ball costs 10 cents. The correct answer is that the ball costs 5 cents and the bat costs $1 more, $1.05. It is important that we have a more granular approach to decision-making in the visualization community. Let's reconsider case study which observed people's decisions about when to leave their house to catch the bus on time. They found that people performed better with dot plot 20 under experimental conditions. In real life, people might be subject to time pressure while looking at the graph and default to gist reasoning. Looking at different types of reasonings under different conditions might lead to significantly different results. There is a need to investigate how gist and verbatim reasoning affect risk behavior and decision-making across different types of visual and decision tasks. We suggest the following research questions. Can we assign people to use type 1 or type 2 reasoning? Do people default to type 1 or type 2 reasoning when using different visualizations? Do people use different types of reasonings for different visual tasks? Does the type of reasoning lead to different types of risk behaviors and decisions? This can have huge implications for visualization designers. By reasoning differently about visualization and its impact on decisions, we can better tailor visualizations to tasks and users with the goal of optimizing decision-making. By expanding our knowledge and having a more fine-grained perspective of decision-making, we can revolutionize the way we evaluate and design visualizations. Thank you.
Wonderful. Thank you, everyone, for those fabulous talks. So we are now going to move into our discussion panel. If you have questions for the panelists, please do post those in the Discord and we will relay them on for our discussion. I would like to introduce our panelists, Ryan Wesslen, Rita Borgo, and Melanie Bancilhon. And I want to ask just a quick question to start us off. I think there are a series of really interesting questions and interesting intersections between psychology and visualization posted here. And I'm curious, how would you all characterize a good model problem for investigating the kinds of questions that you've raised?
That's a really interesting question. Thank you, Danielle. I would say a good model problem for my talk, which was about investigating the differences between different types of decision-making in the way they induce type 1 or type 2 reasoning. One example, like we saw, was to ask people to compute the average of two graphs and to actually see the difference in their actual results. Like I mentioned in one of my research questions, another way would be to see if we can incite these types of reasoning by, for example, prompting the user to think in a certain way, like suggesting some sort of gist level estimate. And on the other hand, having another study group where we prompt a more low level estimate and actually see differences between the two groups.
I can go next. Can you hear me? Okay. So yeah, thanks for the question. Actually, from the point of view of trust definition, it's actually quite interesting because one of the challenge of trust is emerging a lot, especially now that we have to deal with trust in autonomous system, explainable AI, all realities where VIS is providing a real concrete contribution. However, there is an aspect which is quite interesting, and that is to look at what in my talk I refer to as the enablers of trust. And some of these the enablers are not just coming from what is common to us in terms of cognition and perception. They also touch on other aspects, which in a way do link back to also other dimensions of visualization research. So, for example, aspects such as interaction with inanimate objects, how we build, how we build social connections, and all of these themes do have a direct link in different areas of visualizations. So, for me, at this point, one of the model problems that I can envisage is the looking at the building blocks that are behind not only the interaction from, as we have known it so far, but let's say the overlap between
visualization and psychology as we've known so far, but also touching on aspects such as social interactions and interaction with elements which are not necessarily just a graph, but are have a human aspect at the same time, and inanimate aspects per se, which is a very interesting area and something that psychology and philosophy, and in a way even social science at large, have been looking at recently, but has not yet become part of the way we look in our research on the empirical side, for example.
Yeah, can you hear me? Sorry, I'm getting a little bit of issues on my side. I can at least just kind of chime in on really some of the thought process of our paper, where it's more of trying to look at the classical cognitive biases of Kahneman and Tversky, which it's been really exciting the last few years to see several VIS papers starting to incorporate that. But then the real challenge was then trying to understand how we could get some sort of a model to compare that, to almost try to find, you know, bias compared to what, and having some sort of a benchmark to then compare that to. And that's where I particularly, when I took a course in cognitive science, I found this resource rationality, a new take on it, especially around one of the criticisms that I had seen with the classical Kahneman and Tversky approaches is that it really didn't kind of account for Gigerenzer's classical ideas that heuristics can actually make us, that can actually be very fast and frugal as far as the decision making and lead to some smart decisions. And so that's where it was kind of the reconciliation of thinking of the traditional empirical issues that we've seen in cognitive biases, with where especially to build on this is the great push in VIS for Bayesian cognitive modeling. It's a very interesting kind of dynamic to kind of combine both those. And that's at least the paper that we have, think that it's a nice blend and an interesting perspective for VIS researchers moving forward.
Excellent, excellent. Thank you. And again, as a reminder, if you have any questions for the panel, feel free to drop those in the Discord. One other question for you all is thinking about this idea of there seems to be some interesting synergy between all of these different factors that could influence decision-making and interpretation. So Ryan, you mentioned persuasion, Rita talked about trust, Melanie talked about risk. And I'm curious if you could speak a little bit to what you see as some of the most critical factors that we face as a field for understanding how problems might shift decision-making and might shift the biases that we see.
So I think.
Oh, you go ahead.
For your question was about the most critical factors. I think it's kind of hard to put your finger on one or a few factors that are critical to how visualization affects decision making and everything that we see in the world out there. I think one thing also to pay attention to is the combination of all these things together and how it can affect decisions, because people actually make real life decisions from these visualizations. Like I mentioned, health decisions that can literally affect their whole lives. So I think it's important to have a more granular understanding of all these factors, such as, like I mentioned, risk. Trust is also another factor, persuasion, and to really understand how these work together and broaden our knowledge so that psychology and visualization can benefit each other and we can bridge the gap to have a more detailed understanding. Like, for example, my example about when to catch the bus. There are a lot of factors to take into consideration. For example, like how much time are people looking at the visualization for? What decisions are they making? Or we've seen that even factors such as personality can influence decision making when combined with visualization. So I think to redirect your question, Danielle, it will be more of like the array of things that can influence decision making with visualization versus putting weight on specific things, which is what we've been doing so far. But it's important to consider the differences between the two fields and how we can combine them together to advance research in visualization.
Yeah, just to add to that, I think one of the challenges just so classical for Viz research that's so interdisciplinary is just getting the right same language and understanding these different perspectives. So to use the idea of Bayesian cognitive modeling, for cognitive scientists or psychologists, I think that they're much more, there's a lot more history to that versus here at Viz, we've only started to begin getting into that. And I think it's just still a challenge of this. But again, I think that's what's so exciting about this forum, and especially some of the work that kind of takes it one step further than the traditional ways where we might have one-off papers here and there, but really trying to build something towards this and even its own discipline or paradigm in and of itself. So.
Just to quickly pick up on Melanie and Ryan, and then I've seen there are some other questions popping up in Discord, so I want to leave some space to other questions. There is one aspect which for me is quite interesting is that insofar the communication channel tend to be like one way. So psychology comes in and supports visualization supports us in validating or developing our theories. There is, however, space to increase the communication the other way around. So how to use visualization to actually support psychology to better investigate some of this, so I would say fleeting or so polyhedric phenomenon that have so many factors in it. It can be trust, it can be risk, because even on that sense, the way we interact with reality has changed a lot, both for circumstances and advances in technology and development. So a lot of the parameters are changing as well, and visualization has a power in itself so we can benefit from the one-side communication, but can also bring our own contribution in clearing the biases or improving the understanding.
Wonderful, thank you. I want to ask, it looks like we have two questions in the Discord. One is directed, so I'm going to ask that first, and then we'll jump in and we'll close with the second question. So the directed question from Paul Parsons is for Ryan, and it's, many people see biases as the flip side of heuristics. With biased researchers, often a focus on the negative aspects of human decision-making, such as biases that lead to errors. Is there a risk in ignoring the positive aspects of heuristic use by emphasizing biases over heuristics?
I completely agree with that. And that's where, from my own work in Viz, it's kind of the twofold. The Kahneman Tversky is the glass half empty looking at it versus Gigerenzer is the glass half full. And I think so much in the past, and this is what attracted me to resource rationale sort of approach, is that I most of the time kind of looked at traditional Kahneman Tversky that said, when we see issues of anchoring, that's someone that's not, they're irrational in a lot of ways. And that's where I kind of really think that the resource rationale approach, if we can define the constraints, which is actually one of the biggest challenges of resource rationale, typically when we think of these as time, memory, but there could be other sorts of computational resource constraints on us. But if we were able to define that, that's where, especially using the example of anchoring, we could reinterpret that people are not adjusting fully to the right answer because there were huge time costs. Or also as well to the consideration of error. And that's why I found it more appealing, exactly to Paul's point, that there really needs to be a balance, because I think it really depends in a lot of these. And anytime we can find these frameworks, especially one that's very mathematical, which is where I think we're slowly moving towards to making mathematically precise predictions that then we can see experiments and compare on that. That's where I think that there's a lot of promise. And that's, again, where kind of the justification of where I think the resource rationale analysis has some potential.
Excellent, thank you so much. And one brief closing question here from Vantia Damara. Many of us in the Viz community are computer scientists, often without much formal training in experiment design. On the other hand, it feels that while psychology provides a great resource to improve empirical practices in Viz, the stimuli can be a deal breaker. The stimuli in Viz are often quite complex, and if we remove elements of that complexity, the results seem not quite applicable in the visualization context. Do you see opportunities for coordinating our efforts to create create new experimental protocols, yet rigorous, but with more room for visual task or complexity?
Yes. So if I can say yes, and actually the short paper we presented is in collaboration with Darren Edwards, which is from the psychology domain. And I agree 100% with what the point that Evantia is raising. And I think this is one of the objectives of visualization psychology. Because I think one of the challenges is exactly the fact that we need to get on board the collaborations with psychologists, sociologists, much more in a way to also show what are the potentials of more complex stimuli. Now I go on a leap on this, but it's also true that reality is extremely complex, and so we do have in our empirical studies, we do need to also look at complex problems, and stimuli need to have a certain degree of complexity. And it is interesting, even if just reaching a trade-off, but to be able to reach the point of having a solid guideline or a solid conclusion or theory, but something that we can work on to be able to advance the field, to make something which is effective or of impact. And the aim of this workshop is exactly to go in that direction.
Yeah, that's a great question. And I think that experimental design is it's a science of its own, and it's really important. I always find that one of the hardest part of working on a research paper is the experiment design, because I feel like, especially when you're working with decision making with visualization, it feels like everything affects everything. So just to add to what Rita was saying, is definitely something that we should collaborate on and work towards better experiment design, especially for more complex visual stimuli.
Excellent. So with that, I think we've eaten about 10 minutes into the break. So my apologies there, but thank you everyone for sticking with us. I'd like to give a big thank you to our panelists. This has been a really fun discussion, and I'd like to encourage everyone to keep the discussion going on Discord and to join us in about 20 minutes for our second session. Thank you, everyone.
Thank you.
We propose an interactive ensemble analysis framework that provides flexible interactive exploration of the ensemble data. Time series characteristics of data can be obtained by fast browsing time steps. The region stability heat map view shows the stability of the selected region and provides region adjustment by directly clicking.
How many clusters can you see in these images? With different visual encodings in scatter plots, our perception of cluster count changes. We developed models that consider how visual density influences cluster perception. Further, we demonstrate using a threshold plot to optimize the saliency of clusters.
Scatter plots and parallel coordinates are widely used for visualizing multivariate discrete data. However, for multivariate continuous data, the continuous scatter plots and continuous parallel coordinates are more suitable. In this work, we extend them to uncertain data. Additionally, we also extend fibers to uncertain data. If you are interested, come to our presentation.
This is a picture of a Tableau visualization within the browser. The data behind the visualization does not exist here, and Tableau is not running. This is just an image. However, parts of this image are fully interactive. Please join our presentation to see how we can share interactive visualizations across the web, free from any dependency on data or visualization application.
We propose a new semi-automatic method that uses topological features to guide users in tracing neurons, and integrate this method within a virtual reality framework. We use the Morse-Smell complex to find a set of candidate neuron arcs. The candidate arcs are integrated into a VR neuron tracing system and exposed through our Morse-Smell complex guided semi-automatic tracing tool. The topological ridge graph underlying our MSC guided tool is robust against gaps in the signal.
CMED is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMED can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMED provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
The success of a convolutional neural network has been attracting many students and practitioners to learn the exciting technology. However, for beginners, the CN model is not easy to understand. We introduced the Explainer, an interactive visualization tool to help beginners more easily learn about convolutional neural network. Using the Explainer, users can progressively explore the CN model with real-life images in their browser, getting a comprehensive understanding of both high-level model structure and low-level underlying mathematical operations.
We present PowerVis, a tool for visualizing hypergraphs where edges can connect any number of nodes. PowerVis is the first technique to display hyperedges with no overlap or crossing. Vertices are represented as rows, time periods flow from left to right, and groups can be shown on the left. We designed the layout for readability. PowerVis shines with mid-size hypergraphs and it allows detailed analysis. We tested PowerVis successfully using publication datasets and data from historical documents.
VIS is a visual support system for the development of visualization algorithms. It has live compilation, automatic version control, predefined interactions, and tools for visual parameter analysis. By displaying the complete history of the algorithm, users get insights into the correlation between source code changes and visual differences.
SPOT-SDC is a visualization system that helps researchers understand the resiliency of HPC computation kernels to silent error corruptions. It gives users multiple perspectives of details with different granularity about the impact of SDC on an application's output. It also provides novel insight into how silent error propagates through a program's execution.
In this talk, we introduce CallFlow, an interactive visual analysis tool that provides a high-level overview of performance profiles from large-scale scientific applications. CallFlow visualizes the flow of resource of a program execution as a Sankey diagram to detect performance bottlenecks in parallel codes. CallFlow simplifies these calling context trees based on semantic information by constructing supergraphs.
Text alignment is a fundamental technique in many text-related domains. In this survey, we cover 3 text alignment scenarios: collation task, text reuse detection, and translation alignment. On the basis of those scenarios, we reviewed the existing text alignment visualization approaches and discussed their advantages and drawbacks. We finally derived design implications and shed light on related future challenges.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau. Answer questions at the speed of thought.
Attention mechanisms have greatly improved the performance of many language models. Yet with great power comes increased complexity. In this work, we present attention flows, a visualization that let users interpret the language model's decisions and gain insights into the underlying self-attention mechanism. We also support model comparison that helps to fill the gaps between models in different training stages.
We present NL4DV, a toolkit that helps prototype natural language interfaces for data visualizations. NL4DV provides a high-level Python API for interpreting natural language queries. The API automates the core tasks of processing natural language queries to infer relevant information and determine appropriate visualizations, allowing visualization developers to focus more on designing and implementing the user interface.
Imagine you have tons of text data to analyze. And you want to get an overview of your data, but traditional topping modeling techniques such as LDA are not working for you. Then, why don't you try Architext? We introduced a scalable and flexible way to interactively build hierarchical topics.
Deep neural networks are vulnerable to maliciously generated adversarial examples. This brings high risk in applying these networks to safety-critical applications. We developed a visual analytics approach to explain the root cause of such wrong predictions. Our contribution contains a constrained data path extraction method, a river-based visualization, and a contribution analysis method.
Syringe graphs are variants of stack graphs with curve-based line, and the main factor affecting its readability is the sign occurrence through a perceptual inconsistency of the orthogonal and vertical direction. Aiming at reducing its impacts, we revisited the baseline formulation and proposed the concept of composition to help the syringe graph layout optimization. The result shows that our algorithms perform better than the others.
White space surfaces are a novel approach to convey depth in vessel visualizations. The core idea is to shift all additional depth cues away from geometry and to use the usually empty space between the vascular structures. This allows us to display functional parameters on the surface and supporting cues on the background. We will explain how to generate such surfaces and how to use them as a canvas to further enhance depth and shape perception.
Visualizing class separations is used in applications such as classification and clustering. However, many dimension reduction techniques are limited due to the issues of separability and interpretability. We propose a visual analytics framework to support the exploration of nonlinear complex separation structures with the power of locally linear separations.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
If machine learning were like education, we would like to test what concepts our student, the model, has learned. Has it learned the concept of object rotation? Does additional text help with object recognition? We need a methodology and platform for conducting such tests. In this paper, we present a novel visual analytics tool that enables hypothesis-based evaluation of machine learned models.
Asteroids have always been and will always be a threat to life on Earth. Most likely, an asteroid will hit deep water, but what properties will actually lead to a threat like a tsunami? Ensemble simulations are a common tool to understand the effect of different parameters like the size of the asteroid. We propose an interactive visual approach to help analyzing deepwater asteroid impact simulation ensembles.
We present TransVis, a design study that is proposed to analyze and integrate close and distant reading of multiple translations. TransVis presents the overview of the collection to capture global patterns that is facilitated by the IEEE VIS matrix. TransVis integrates a detailed view to explore interesting path of alignments. We also propose the TLC view to examine and explore the terms of the user selected path to justify and reason the ID analysis.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
We present Lyra 2, a system for designing interactive visualizations by demonstration. To design interactions in Lyra 2, users directly manipulate the visualization canvas. The system interprets demonstrations using heuristics and suggests possible interaction designs. We find that Lyra 2 enables rapid prototyping of an expressive range of interaction designs. We're excited to share this work with you.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
As data is changing, our understanding of data should be updated correspondingly. Based on machine learning approaches, we formulate a drift-level index to monitor the evolution of multi-source data, which allows users to capture and reason significant changes from time series data. The proposed visual analytics system is called Concept Explorer. More details can be found in our talk.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results. For example, the Markant brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brushing model which takes the user in a loop to improve the brushing accuracy.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
Digital humanities present great opportunities for testing new visualization approaches and evaluation techniques. However, and given the diffuse character and novelty of the field, it may also be intimidating for novel and senior researchers willing to get started in the discipline. In this paper, we propose a data-driven analysis of visualization for the digital humanities to identify key themes, authors, and relevant publications. So if you want to know more, please read our paper.
Welcome back, everyone. We're excited to start our second session. In this section, we are going to be focusing on task-driven approaches. And to start us off, we have a paper by Darren Edwards and Min Chen entitled Developing Effective Community Network Analysis Tools According to Visualization Psychology. Immediately following the video, we'll do short question answer, and then we'll do a full question with the entire panel after the 3 papers that we present.
Okay, so this is a talk about developing effective community network analysis tools according to visualization psychology. So within the realm of health psychology, we have a range of different disorders, heart disease, stroke, cancer, etc. And they lead to certain psychological outcomes such as stress, smoking, weight, etc. We have certain biopsychosocial models which are help us to predict and identify certain interventions to help with these particular disorders. And one way that we can help facilitate the health psychology community is by engaging with certain visualization tools such as community network analysis tools, which typically use something called Cohen's K and produce node link diagrams. Now, this is obviously an example of data visualization aiding and facilitating health psychology in this particular example. But we have to ask broader questions. Broader questions could be things like, can we actually trust these visualization tools? What is the risk to healthcare professionals? What is the risk to researchers, and what is the risk to patients? So to what degree can we actually trust these visualization tools? So this could be a prime question for a subject area such as Viz Psych, who are interested in things like trusting these visualization tools, typically within a psychology domain, where psychologists are looking at these visualization problems, not just at an application level, but at a more fundamental level. So Viz Psych is not something that is a psychology or data visualization. It's somewhere in between. It's something that is aiding both domains by looking at these more fundamental questions. So we know how psychology may help visualization. It can help with obviously spatial memory, working memory, motivation, confidence, visual search, trust, and so forth. Now, an example of this in the area of epidemic management, we could ask, for instance, can visualization improve cognitive effectiveness and efficacy in monitoring processes? With data visualization, will data analysis suffer from things like intentional blindness? So we're asking, to what degree can these visualization outputs actually have a negative impact to maybe a health psychologist who's trying to help his patients, or the NHS or something? So we're asking, will it lead to things like intentional blindness? What are the limits of working memory? Can that affect our processing of visualization patterns? And we want to be able to collaborate and communicate with others in the community and the people that we're trying to serve more effectively, but we don't know the limitations unless we study these things. So it's about visualization psychology is very much about the studying of these more basic visualization properties from a psychology perspective. Now, should data analysis share their visualization images with the public? And how is the interpretation of visualization affected by things like knowledge and experience, tasks and motivations, emotions, language, and culture? Again, very much psychology-based type of questions, which can facilitate the visualization community, which can then strengthen tools, which then can facilitate the psychology community. Example 2, in community care and management, can visualization help motivate patients to follow a treatment plan, to reach out to others in a similar situation? Again, questions that could be asked within a visualization psychology domain. If so, what are the cognitive considerations, which include emotion and motivation, as well as many aspects of social psychology? What are the differences between using visual and non-visual means? So we can ask all of these questions. So in conclusion, cognitive investigations into visualization start with using visualization in a community network analysis. That might be a good starting point. Then expand to using visualization in other aspects of health science. So we can start by looking at the actual tools and asking these kind of more fundamental questions about bias and whether we should trust these tools, and then expand to what are maybe the applications to developing new models in health psychology. So we're fundamentally trying to draw generalizable conclusions on fundamental questions about visualization. So we feel that this might be a better way of creating strong focus on these more fundamental aspects about how we can get psychologists on board learning about visualization who may typically not even be familiar with visualization, Psychology has a major problem right now with lots of individuals not even understanding anything about these visualization tools. So there's limited communication with the visualization community at this stage, with it largely being a cognitive community. So again, one of the motivations is to broaden the scope of visualization within psychology and drawing more people from psychology to study visualization, develop these tools, and then focus on the appropriate applications. Okay, so
great. Thank you so much, Darren. That was a great talk.
much.
I have a quick question for you. Great, thank you, Darren. I really enjoyed listening to that talk. I have a quick question. I don't see any questions right now in the Discord. If you have them, please post them quickly. But Darren, you talked quite a bit about thinking about trust and biases, and this was a theme from the last discussions as well. My question for you is, because you've worked significantly in healthcare communication, how do you think about defining what's a negative judgment or what a bias is?
So I think the previous session kind of like looked at a whole variety of different kind of like biases, like risk, trust, so forth. I think with the cognitive community, I think they're a bit kind of sharper, and they're more aware of, you know, things like biases in terms of memory and attention and those kind of things. When it comes to the health domain, they're much more naive with the use of visualization. So it's a risk when you're dealing with the public, when we've got things like coronavirus and we're using these visual aids to say, oh gosh, you know, this is happening. People can just look at these visualizations, and we know just from simple, you've seen these graphs, and that's how easy it is to manipulate our perceptions of, you know, data just by having like a graph, for instance, which might be just 2 decimal points, but just zooming in, it looks like that. You know, just that kind of instance. For someone like a health psychologist who's kind of unaware of these kind of biases, this can be hugely problematic. So for me, I was thinking about how we can actually engage, you know, the health psychology community, again, who are less familiar with these visualization tools, and how we can communicate the risks and biases. So the risks and biases, to me, are very straightforward. It's very much how we're actually interpreting the data. And I'm sure a lot of health psychologists will jump on board and say, let's use these community networks. But the risk there is they might be very naive, because they're not caught up in the literature about how these tools and these visualization can actually mislead the conclusions, the user. So there's a lot of scenario, there's a lot of risk factors there. There's also who you're presenting the information to. So like locus of control. If you're showing a certain diagram with someone with low locus of control, they might externalize and believe a graph more than their own experience. So, you know, I think we have to look at, you know, who we're showing these graphs to, what's their background, what's their knowledge base, and, you know, if they're a particularly vulnerable group, you know, maybe a subclinical, someone with Asperger's or something like that. Be very, very careful about using these tools. All of these things have to be really, really explored in detail, because there's potentially a real risk for, you know, danger if we don't. So there's an absolute paramount responsibility, in my opinion.
I think it's not, I mean, none of these are self-explanatory, you know, anything beyond a pie chart, and pie charts are misunderstood. You know, we've done work with physicians, and we did work with Boeing, and the Boeing safety analysts are really good aircraft mechanics who've moved up the food chain, you know, and then they have a safety board, which is more the business. And at each pass from the analyst to the engineer to the board, they get less and less capability. And so our approach was to package the technology with a student, and this was the pair analytics, and the student understands how the visualization can mislead and understands how to use the software. And so you have this little dyad, and they're teaching each other. The student's teaching the engineer how to do the analysis in terms of the visualization and the software and how it's misleading. And then we capture the whole thing. We capture the video, we capture the audio, we do key press. And so we get this huge ethnographic data dump, which we then have to go through. And that's with the Clark's joint activity theory. But we're creating this job category of visual analysts, which is someone, and Boeing hired the student to do this, have laptop will travel. They dump him into some place, he brings up all of the Inspire and Tableau and everything else, and then does this whole process with their analysts.
Great, thank you. Everyone please join me in thanking the speakers. Next up is we will hear from Kuno Kurzals, and his talk will be on what we see and what we get from visualizations, eye tracking beyond gaze distributions and scan paths.
What we see and what we get from visualization, eye tracking beyond gaze distributions and scan paths. My name is Kuno Kurzals from the ETH Zurich. This is a collaboration with Michael Burch from the TU Eindhoven and with Daniel Weiskopf from the University of Stuttgart. This talk is about eye tracking and visualization research and how it would benefit from a stronger connection to psychology. Eye tracking is an important measure for the evaluation of visual stimuli, such as visualization. We can see this on the increasing number of eye tracking studies conducted in the main VIS venues and related areas over the last decades. Please note that the last years are missing in this chart, but eye tracking is still used in many evaluation procedures. By investigating how people look at visualization, we can analyze their visual solution strategies and identify possible design flaws in case they are confused. When we look at most of the eye tracking studies related to VIS, they analyze standard eye tracking metrics, gaze distributions, scan paths, or try to classify gaze behavior. As a short example, I want to show one of our previous eye tracking studies on metro maps. We conducted this study to compare how grayscale and color influence wayfinding tasks on such maps. Participants were asked to find a correct connection from an origin location to a destination. In terms of performance, color was significantly better. People reported the correct route much faster than with grayscale maps. Looking at the eye tracking data was really interesting because it showed us how people explored different routes. On grayscale maps, we could see that people perform much more cross-checking between origin and destination, which we interpreted as a sign of higher uncertainty about their solution. But, except for these observations, we could not explain behavior. Also, the cognitive processes involved in this task are unknown. Our study design did not consider this aspect. We could show that color is better for this task, but we still had one question in mind. How could we improve the maps concerning perceptual and cognitive processes? To answer this question, we would need more expertise in psychology and cognitive science. So why did we not have this expertise, and why is there in general not so much work on visualization and psychology in this area? In our experience, there are some reasons for this situation. First, researchers have a different background. Doctoral students in VIS would have to learn about eye tracking and psychology to conduct such research. And doctoral students in psychology would need knowledge in computer science and VIS. Furthermore, we noticed that research interests are often a reason why collaborations are hard to maintain over multiple projects. Researchers have different publication strategies, and visualization is not a core topic for psychological research. And from a practical point of view, the tasks in a study are often very different. While tasks in psychology are designed to induce cognitive processes, the tasks in visualization research are often very complex and also serve as a measure for performance and the quality of the visualization. While these are, in our opinion, the reasons why we do not have a large visualization psychology community, we now want to outline why it would be good to have one. We see visualization psychology for eye tracking experiments as a combination of knowledge from visualization, eye tracking, psychology, and cognitive science. So, how could we benefit from visualization psychology? For example, we could improve the quality of study designs with the experience of psychologists. One way of improvement would be study designs that are more based on perceptual and cognitive theories than on exploration and observation alone. It would also help explain observations from user studies when specific behavior can be linked to cognitive processes. And finally, cognitive architectures that model the behavior of people interpreting visualization could be developed. This would be beneficial for numerous aspects of visualization design, as such models could analyze new techniques before a user study is even necessary. The open question I want to end this talk with is: how can we integrate the expertise from both research fields in a common research endeavor? Common venues such as the Symposium on Eye Tracking Research and Applications, workshops such as this one, and interdisciplinary research centers are a good start. Overall, we see visualization psychology as necessary if we want to understand how visualizations work in our mind, beyond the things we can currently observe. And eye tracking is one important means to achieve this goal. Thank you for listening to my talk.
Okay. You can hear me?
Yes.
Okay.
Thank you so much, Kuno. That was a fantastic talk. I really like thinking about eye tracking as this kind of task category that's really at the intersection of visualization and psychology. And I'd love to get your thoughts on if you have advice for visualization researchers that are considering incorporating eye tracking or doing a collaboration with a psychologist. What situations do you think would actually benefit from eye tracking? Is there, not everyone, I don't think it's probably useful to say that everyone should always do an eye tracking experiment, but do you have guidance for if someone's considering doing an eye tracking study, what they should think about, and just critical considerations?
Many of the experiments that we did and that I described here was mainly doing observations. How does the viewing behavior change when you look at specific visualizations or animations or so? So I would say it's working that you can find out if a person is confused by your visualization. So if you would just want to find that, I think that's possible right now. If you want to go deeper, find out why this specifically is, if it's not that obvious from real design flaws that you made, then yeah, it gets more into this direction that we wanted to see in the future, where you also include these cognitive considerations.
Great, thank you so much. Please join me in thanking Kuno again. There'll be lots of discussion in the panel as well. I already see many discussion points coming up. All right, next up we have a talk aptly named Task Matters by Laura Matson.
Hi, I'm Laura Matson from Sandia National Laboratories. I'm presenting the paper Task Matters when Scanning Data Visualizations. So a perennial question is, what makes a data visualization effective? One way to come at that question is to look at how well the visualization supports the viewer's cognitive processing. So we know that the perceptual aspects of a visualization influence viewers' cognitive processes. So for example, changing the visual representation of the same underlying data set can change how people interpret that data. We also know that viewers tend to look at the most visually salient regions of a visualization first, so changing low-level features such as saliency can change viewers' patterns of eye movements. But we know that top-down factors such as task are also very important. So people might use the same visualization to support different tasks, and we know from the visual cognition literature that changing tasks changes how people look at things like natural scenes. So in this example, giving people the task, how many floors does the tallest building have, leads to a very different pattern of eye movements than giving them the task, how many cars are in the scene. So the same thing should be true for visualizations, but not many studies have investigated the impact of task on patterns of attention or patterns of eye movement in visualizations. Studies looking at the relationships between tasks and visualizations have usually focused on identifying which visual representation is best fit for a particular task. There are hardly any studies that have used a single visualization and manipulated the task to see how that manipulation impacts where people devote their attention or their eye movements. We'd argue that more research along these lines, looking at how different high-level tasks impact attention to different aspects of visualizations, would allow for both better evaluations and a richer understanding of visualization cognition. So here's a simple example where we did an experiment on the impact of task on viewing patterns for scatter plots. So our participants were 30 people from the University of Illinois. We did a within subjects experiment where we manipulated task, which was describing the trend in a scatter plot versus describing the outliers. And we manipulated the data pattern with 8 different types of trends and the number of outliers in the stimuli. We had a total of 32 scatter plots, 4 unique plots for each of 8 types of trends. The trend data points were constrained to fall within 2 standard deviations of the trend function, and half of the stimuli had 2 outliers while half had 4. The stimuli were divided into 2 balanced blocks. The participants saw the blocks in the same order, but half of the participants did the trend task for the first block, half of the participants did the outlier task, and then they switched tasks for the second block. Here's an example of 2 of our stimuli, one that has 2 outliers and one that has 4. We recorded subjects' eye movements using a Smart Eye Pro eye tracker. Each trial began with a 1-second fixation cross. Then the scatter plot was shown for up to 10 seconds, although participants could advance whenever they were ready to give their description. When they advanced, they saw a blank screen, and from memory, they provided a verbal description of either the trend or the outliers to the experimenter. We assessed the participants' behavioral performance by having 2 raters independently score the participants' descriptions. So on the outlier task, the scores were based on how many outliers were identified. Participants missed a fair number of the outliers. They missed 1 or more of the outliers on half of the trials, but we didn't see any significant differences across the trend types, and overall they found most of them. For the trend task, the scores were based on the completeness and accuracy of the participants' descriptions. So our 2 raters agreed that for the participants' descriptions indicated understanding of the trend for 87% of the stimuli. So overall, the participants did a good job at these 2 tasks. To analyze the eye movement data, we divided the stimuli into regions of interest, including the outliers, trend, the title, the x-axis and label, y-axis and y-label, and other, which was the background region behind the scatter plot. In general, we found that the participants had more and shorter fixations in the outlier task than in the trend task. Based on prior research, that's a trend that's indicative of visual search. So the participants were searching around the image looking for the outliers. When we look at the proportion of fixations to the different regions of interest, we see, as expected, that people are significantly more likely to look at the trend task when in the trend condition than in the outlier condition. And similarly, in the outlier condition, they spend more of their time looking at the outliers and the other region, which is where they're searching around to find those outliers. Here's an example of one of our stimuli. On the left here, we're showing a heat map of fixations for all the subjects who looked at the stimuli and did the trend task. And over here we have the outlier task. The arrows point to where the outliers were. So you can see that in the trend task, people fixated on the trend and on the axis and axis labels and on the title. And the outliers, they spent most of their time looking at the outliers. Here's another example. We see this pattern over and over again for all of our stimuli. I think a nice way to look at this data is to borrow a visualization from the psycholinguistics literature and look at the probability of visiting each region of interest over time. So in this top panel here, we have the outlier condition, and the outlier region is represented by this blue line. So right at the start of the trial, at 0 milliseconds, the image comes up on the screen. People are immediately looking to that background region, and they spend most of their time throughout the whole trial looking at that region, searching for the outliers. The yellow line is the proportion of fixations, or the probability of fixating the outlier region of interest, and that is relatively high across the entire trial when you compare it to how often people look at the outliers in the trend description task. In the trend task, when the trial begins, we see people look at the trend ROI, which is this orange one right away. Then they look at the axes as they're formulating the description, and they tend to look back and forth between the trend and the axes for the remainder of the trial. So yes, task does impact patterns of eye movements for data visualizations, and this just demonstrates that we need to take bottom-up and top-down factors into account when evaluating visualizations. So assessing visual saliency is very useful, but combining it with an assessment of common patterns of attention for particular tasks is even better. I think that a good starting point for doing more research along these lines is to use the taxonomies that have developed in the VIS community for identifying common tasks. So here's an example of a taxonomy of high-level analytic tasks. I've highlighted the ones that were represented in this experiment. These could also be applied to other types of statistical graphs. There are also taxonomies that are more domain-specific that could be used to guide research along these lines. So to summarize, there are several benefits of using eye tracking to assess the impact of tasks. It furthers our understanding of how people make sense of data visualizations. It helps us identify situations where visual, spatial, and cognitive biases arise. And it can aid in the development of widely applicable evaluation models by taking both bottom-up and top-down aspects of visual cognition into account, so we can determine whether a visualization effectively meets its users' needs. Thank you very much.
Okay, great. Just give me a countdown when I'm live. Laura, do you want to answer general questions? There's a lot of general questions about eye tracking. Why don't you just open up to the panel directly, but I'll first ask some questions to Laura. Fantastic. Thank you so much, Laura. That was a very interesting talk. We have many questions in the Discord. Everyone's getting very interested in this topic. I'll begin with a question kind of more specifically to your paradigm. So I was interested to know if you have thoughts about, this was from Enrico Bertini. Sorry, I'm scanning down to it. Oh, here it is. He writes, I like the idea of seeing eye tracking as a way to have a glimpse into what happens between interactions. Think aloud protocols seem to achieve similar goals with much less complexity though. Do you want to just elaborate on the advantages and disadvantages of eye tracking over different methods in your paradigm?
Yeah, sure. So we've also used Think Aloud protocols in some cases. And in my work in particular, I'm often working with people who are experts in a particular task, and we found that they often struggle to verbalize what they're doing. So often the eye tracking, they'll say they're doing one thing and the eye tracking reveals that they're actually doing something different. So that's one thing to be aware of, is that especially working with people who are experts at a particular task, they have a hard time sometimes on the think aloud protocols actually articulating their thought processes or their approach to the task. And eye tracking can reveal different things that they aren't sort of consciously aware that they're doing. We're facing the same dilemma as a lot of eye tracking researchers, that we can't collect eye tracking data right now. We've explored using artificial foveation techniques instead. So that's where we track people's mouse movements and we blur everything on the screen that's not right around the mouse. And we can collect data like that online. We've tested it for visual search tasks and found that we did see very similar search patterns when comparing the mouse movements to eye tracking. So I think that's a method that could be useful. It can be done remotely and it requires much less technical setup than eye tracking. So that's another alternative. I think it's worth exploring more.
Great, and sort of a follow-up question about thinking about different tasks. So it can be difficult to optimize a visualization for a single task, and your work suggests that the task matters. So do you have thoughts about how to create visualizations that support different tasks?
Yeah, the one thought I've had from the discussion this morning, the discussion about the differences in the complexity of stimuli and tasks in viz research versus psychology research. I think one place those might be able to come together is using the same visualization to support and studying how people use it to do different tasks like we did here. Since a lot of visualizations are designed to support multiple modes of interaction or data exploration, things like that, where people are using them in a more open-ended way. And so it is really, psychology experiments do tend to reduce stimuli down to something very simple. But I think we could also take the approach of keeping the stimulus the same and even using something pretty complex, but manipulating the task and looking at how that changes how people interact with the visualization or what they gain from using it. So that's just a thought based on this morning's discussion as well.
Great, thank you. Please everyone join me in thanking Laura, and let's open up the discussion for the entire panel. There has been many questions posed in Discord about eye tracking specifically. And thank you, Kuno, for kind of fielding some of those questions on Discord. I think I want to kind of pose this to everyone. This is from Amy Fox. She writes, I'd be curious to know what the speakers think of algorithms that are for gaze patterns based on webcams, which Laura kind of just talked a little bit about. Are they pretty precise enough to use for this kind of research? Has anyone else tried those types of methods?
Should I start? I would think it's all a question of the precision. So if you're interested in, for example, a visual analytics system that consists of 4 different views, and you're just interested when people looked in one of the views, then you don't need that much precision. If you want to really go more into detail, I mean, there is probably a reason why the eye tracking hardware is so expensive when the precision gets higher. And it's about also reliability. I think with the whole webcam tracking, it's on a good way. Still did not try it, I have to say. But yeah, if you design your experiment in a way that you don't need that much precision, maybe that's already possible to some degree.
This is sort of a related question on the same topic. Someone writes, I wonder if there's reliable alternatives to eye tracking if you'd like to use psychological methods in visualization studies. Not all research teams have the tools to do eye tracking, especially now amid COVID. So I think this kind of relates to the topic of what is necessary for your experimental question. Are there any alternatives to eye tracking that maybe could get at similar types of measures that you have worked with?
Yeah, well, I think it all depends on what question you're asking. And in many cases, you can design a study to answer that question where you don't need eye tracking or additional measures like that. So I think you can, think about what the key question is and design the experiment accordingly, but it could require totally rethinking how you're setting up the task in some cases.
From a health perspective, again, we're looking at different users, in terms of communicating information and so forth. We don't necessarily need to use eye tracking. Eye tracking is a very, very good way. There's tons of stuff on like visual eye tracking. There's a lot of stuff with, for instance, what that person's background is. So if someone had like alcoholic abuse, you had certain images with like alcohol images coming up, you'll see, it's like a Stroop task, you'll see their gaze moving over and priming stimuli. So again, in terms of my talk, where you have to be very sensitive to who the user you're communicating this information to, I think, we have to understand what kind of things are shifting focus, what's leading to those certain cued responses where vision and eye gaze is going to go. I did a couple of studies a few years ago with autistic children, and rather than doing like eye tracking, so we had very simple like two-dimensional stimuli. We could have done eye tracking, looking at the body and the legs. So a normal person would look at body and legs for a categorization task. So all we did is just looked at how they categorized the information, and we could easily tell if they were categorizing it just on the leg information, you'd have big legs together, small legs together, regardless of body size. So there are ways to kind of get around visual tracking by looking at, categories and how stimuli is put together on the basis of dimensional features. So I just thought that would be a useful way in terms of how to design experiments in the future, is like, number one, looking at what kind of user group you're looking at, what might prime vision, and kind of like looking at the information theory perspective in terms of how does an individual categorize and put things together and sort things, because we can infer things about eye tracking on the basis of behavioral outputs.
Yeah, a good point to follow up on sort of inferring information, all trying to get at the same sort of underlying processes. Barbara Tversky writes, other alternatives to eye tracking tends to pick up on lower level visual features. What they found is it can also be useful to use mouse tracking, that is having people use a mouse to track what they are looking at. Then they click on places on the screen where they are pausing to think. This is a cognitive tracking. Now, this makes me think of all of this relating to something that Barbara talked about, which is, how we form sort of a spatial understanding of the world. And I'd love to hear your thoughts in terms of how you use eye tracking to infer sort of the spatial organization and how much you can infer, because it is an inference. We're not seeing exactly what's in someone's mind, but you all have more experience kind of making sense of the eye tracking information in terms of how we're inferring what spatial information we see.
You asking me or Laura?
Everyone. Anyone. Barbara, you can answer too if you want.
Barbara's here. We ask Barbara.
So yeah, thank you, and thank you for picking up on that. And I would really be interested in what the speaker thinks in terms of having more experience using eye tracking. But exactly because eye tracking picks up on low-level features, we did try only in one study this mouse tracking, and it was exactly to pick up the spatial structure. So people were scanning drawings, not visualizations, but it would be wonderful to try in visualizations. And we found that the path through the visualization was quite similar across people. And it would be interesting to try data visualization or information visualization, especially with the idea again presented that different mindsets will cause different tracking through it. So to me, it would be an exciting way, and I think it's cheaper. I mean, eye tracking equipment is now cheaper, but this mouse tracking could be even easier to implement.
So
But
one
again, I'd be
question.
interested in the speaker's thoughts on that.
Barbara, one question. So in your experiment, you did not eye tracking with the mouse. So you were just tracking the mouse and gave them the instruction to follow their gaze.
Okay, so that's
So
what you were doing.
No, what was it like this in your experiment?
What's the question?
Yeah, if you did it like this, so no eye tracking, and you asked them to follow their gaze with the mouse. Did I understand this correctly?
Yeah, it's sort of even more than gaze. What are they thinking about to track what their thoughts are? Yeah.
Yeah, we had some experiments where we also tracked gaze and the interaction with the mouse. And there you could notice that people really act differently. So some really follow and others just look around before they do anything with the interaction. So there was kind of a difference between the user groups, I would say. So without...
That's really interesting. I worked with an artist who was tracking that on people's drawings. These are artists constructing drawings. And some of them did what your people did. They kind of drew all over, sketching out. And some started in a specific spot and then began drawing. And it was an interesting way of comparing artists and seeing. So yeah, that would be fascinating. Who looks around all over and who starts a track. We did a little bit of work on descriptions of maps that showed similar things where people were describing what they were looking at. And some took an overview and then went into detail, and some started a route. And there it depended on the map. If the map showed many structures at many levels, had a hierarchical organization, then people started with an overview. And when it didn't, it was flat, people sort of went on a route.
Yeah,
So,
we had similar experiences when we looked at the metro maps. So there were different studies we did on people doing wayfinding tasks on the metro maps. And there you could also really see different strategies with eye tracking. There it was really helpful. So yeah, I
right.
mean, the low-level features, that's true. But for general strategies, I think it was really helpful to use eye tracking.
Yeah,
And
yeah. And it shows both effects of the visualization and of the set and individual differences. So all those factors are going to be important. Yeah, thank you.
Thank
That
you.
was a great discussion. I'd like to advocate for mixed methods, using lots of different approaches to do the same thing. So with that, let's thank all of our speakers in this panel. Great job, everyone.
Thank you.
Now move on to the next panel session.
Okay, welcome everybody. So we are now moving on to our third session, which is entitled Frameworks for VIS, which is for Visualization of Psychology. We have three really interesting papers, and the first one is going to be presented by Amy Fox, and the title is More a Question, and it is A Psychology of Visualization or External Representation. So Amy, the stage is yours.
In the call for proposals for the 2020 VIS Psych workshop, the organizers offered a compelling thought experiment. What would a new subdivision of psychology look like? One that's entirely devoted to the study of visualization. If we construe this visualization psychology as a research program in the tradition of Hungarian philosopher Imre Lakatos, then we have to decide what ideas will sit at its hard core. What are the central theses or foundational assertions that are held to be true in which the science of the program are grounded? It is from these foundations that we are meant to derive specifical empirical hypotheses, what Lakatos termed an auxiliary belt, and the act of our science progresses by testing, falsifying, and revising these auxiliary hypotheses. So what belongs in the hard core of a visualization psychology? In my position paper, I argue that rather than building on prior work solely in visualization, we should build our foundation upon a larger body of work on external representations. I'm externally representing to you all right now by transforming the thoughts in my body into the environment, where they're perceivable by myself and others in this moment or persisted through time. The artifacts of this process are what we call external representations. These include sketches, diagrams, charts and graphs and plots, and the things we colloquially refer to as visualizations, but also things that don't, like systems of notation and even text. External representations have been an object of study across disciplines, including computer science, human-computer interaction, cognitive psychology, learning science, science education, and communication studies for decades. We know a great deal about how external representations work, both from information processing and situated in cultural perspectives. A visualization, then, is a subset of this larger class of external representations. I argue that the cognitive, perceptual, social, and distributed mechanisms that govern this larger class also apply to the study of visualization. When we study a visualization, we're studying the function of an external representation, the construction of meaning in a distributed cognitive system. This construction of meaning is often followed by some intelligent action with that meaning, be it learning, making a decision, solving a problem, forming a judgment, or any of a multitude of complex cognitive activities which form the communicative context of the representation. I argue that the conceptual structure of external representation offers us three benefits. First, they help us think about processing via multiple sensory modalities. External representations can be constructed for any sensory modality, though by far the most attention has been paid to the visual. I suggest that we take into our scope the challenge of multisensory representations. From a theoretical stance, this requires a broader inclusion of expertise across subdivisions of perceptual psychology, but the applications here are really consequential. In an increasingly visualization-driven workplace, equity and accessibility demand that we create informationally equivalent artifacts for individuals without visual perception. I think this is exactly the kind of challenge that a visualization psychology could excel at. Secondly, they help us think about processing via multiple encoding media. We often refer to encodings as dimensions along a continuum. For example, from descriptive to depictive, or symbolic to analog, propositional to graphic. These terms refer to a semiotic modality, which we also call a medium, and this indicates the degree of convention or how arbitrary the relation is between a representation and the thing to which it refers. Although the poles of this depictive descriptive continuum can be easily identified, the things that lie between are more murky. Rather than describing visualizations as primarily graphic in order to distinguish them from text, I propose that we're more accurate in describing our scope of inquiry as fundamentally multimedia. Although the origins of our field lie in the distinction of graphics from text, there are fundamental questions about framing, persuasion, and even comprehension that rely on understanding the function of graphics alongside text. It's rarely the case that any form of external representation of the visual graphical variety is not accompanied by some form of linguistic proposition or notation. Indeed, a visualization without a title or labels might be worth no words at all. Finally, I argue that the perspective of external representations gives us a framework for thinking more broadly about the varied purposes that visualizations might serve. Many visualization textbooks describe the purpose of a visualization as being to amplify cognition. But as psychologists, we appreciate that the story is more nuanced. What kind of cognition are we amplifying, and to what end? We can think of the most generic case as being communicating to simply inform. For example, the box plot in my manuscript or the bar chart in the newspaper, where my aim is to inform the reader of some aspects of the underlying information in as clear a manner as possible. But I might design that artifact differently if I want you to explore the data, to undertake an analysis, make a decision, form a judgment, or make a forecast. I might offer you a different set of interactions if I want you to use the visualization as a tool, perhaps for planning. I will certainly change my strategy if I want to strongly persuade you, or alternatively, if I want you to use the representation as a tool for learning. Now, in my teaching, I use the term communicative context to refer to these cognitive activities that the designer of a representation intends for the user to perform. The insight here is that there are certain parameters of the representation's design, such as the computational efficiency or relative explicitness of certain aspects of the data, and they need to be tuned in accordance with the task the reader is expected to perform. I conclude my position paper by arguing that by adopting this broader scope of external representations, our nascent program in visualization psychology positions itself at the boundaries of established scholarship in visualization, alongside researchers exploring really interesting topics like data visceralization, accessibility and multimodal communication, multimedia learning, and the entire community of scholars who share our interest in diverse communicative artifacts. I hope you'll take a couple of minutes to read the paper, and I'd love to hear your feedback and engage in conversation on this topic, especially relating to communicative context, taxonomies of activities, and the role of semiotics and information in any visualization psychology. I'll wrap up now with a huge thanks to the workshop organizers for giving us this great opportunity and for spotlighting the importance of psychological perspectives in visualization research. Thanks, and I look forward to chatting with you soon.
Okay, am I live? Mm-hmm. Okay. Thank you, Amy. A very interesting talk, and we have time for a one question probably. If there is anything on the Discord channel, otherwise I will go ahead and ask a question myself. So, okay, so at the moment, nothing nothing as shown so far. So Amy, I have a question about the framework that you are proposing, or maybe design space, because it's so rich and it's very interesting. So I wanted to know, do you see any challenges, any immediate challenges in focusing on external representation? Because you have mentioned semiology, and also external representation have the characteristic of having very well-defined categorization. So could there be a bias in the way we develop this categorization that can be influenced by the context, the culture? Semiology has a dimension which is extremely influenced by one's own traditions and culture.
Oh, that's a great question. I love that question. Thank you. And I apologize, I have to leave my video off because I'm having some bandwidth problems. I think the bias that could be introduced there is the blessing and the curse. So it's a curse in that it introduces additional complexity, but it's a blessing in that it is the actual underlying context of how the representation is processed by any individual that's situated in an environment, situated inside a culture. And so as we sort of broaden our scope out to larger levels of analysis, depending on what the focus of our work is, we need to begin to consider those broader contexts, right? And that's why in the position paper, I try to make the argument of, particularly with respect to multimedia encoding, and understanding that even if we're primarily focused on the graphic components of a visualization, those may not be understandable without the accompanying text. And so, I don't suggest that we think about external representations to introduce additional complexity or exacerbate the inherent information overload that we all have when we're trying to do literature review, but rather just use that as an opportunity to import ideas from relevant communities that have already been thinking about these things for a really long time. And I'd encourage folks, particularly from the visualization community who maybe are newer to psychology, to definitely take a look at all of the work in learning science and educational psychology, because there's a lot of really great work there, particularly stuff in eye tracking, all of the stuff that Barbara's talked about, so it falls into that category, where these visualizations have been considered, but in sort of this larger context.
Fantastic, thank you very much. So presentation is how do visualization designers think, design cognition as a core aspect of visualization psychology. So Paul, whenever you are ready.
There are numerous opportunities for engaging in research at the intersection of psychology and visualization. While most opportunities taken up by the VIS community will likely focus on the psychology of users, there are also opportunities for studying the psychology of designers. Here I present a case for the importance of studying the cognition of designers as a necessary component of a holistic program of research on visualization psychology. Design research in VIS has largely focused on modeling design activity. Popular examples include various process models and decision models. Although decision models focus on the decisions that designers can or should make in design situations, they do not engage with decision making at the level of cognitive processes or structures. Thus, there's a large gap in our understanding of how and why such decisions are made and the psychological factors that influence their outcomes. Studies in design cognition investigate how and why designers think the ways they do while designing, rather than focusing on tools and actions and processes of designers. Design cognition has been studied across a wide variety of domains, including engineering, architecture, computer science, instructional design, and graphic design. Across these disciplines, a wide variety of issues related to cognition during design have been investigated, including, among others, episodic memory, fixation, chunking, bias, abductive reasoning, analogical reasoning, metacognition, and recall. Much of the research on design cognition is concerned with how designers navigate the complexity and uncertainty of real-world design practice. A number of core strategies have been identified through empirical investigation, including conjecture-based problem formulation, problem-solution coevolution, analogical reasoning, mental simulation, and fixated solution generation. Many of the cognitive processes that are relevant for studying the use of visualizations are also important for understanding their design. For instance, studies have shown that designers rely on chunking to ideate effectively. They employ abductive reasoning during concept selection. Designers are influenced by color in ways that bias their thinking while sketching, and they also struggle with fixation while generating ideas. Given the considerable evidence of such issues impacting design across numerous disciplines, it's very likely that these are also important for understanding how and why VIS designers engage in their practice. There's sometimes an assumption that design is simply an application of knowledge generated from scientific research. This view suggests that if designers understand the principles and concepts that come from research well enough, then they should be able to simply apply them in their design work. This view was prominent in multiple disciplines decades ago, but it's since largely been abandoned by design scholars as it's shown to not accurately reflect the true nature of design practice. While scientific knowledge certainly plays a role in design, it's not sufficient for good design. Rather, designers have been shown to have their own ways of knowing and acting that are highly personal and situated. Thus, even if we develop a robust program of research at the intersection of psychology and visualization, if its scope is limited to users only, we will fail to really understand how to influence design practice effectively. Because design cognition has a rich history in other disciplines, there are numerous research opportunities and questions that can be borrowed from these disciplines and applied to VIS. One approach for doing this kind of work is to look at research questions that are posed in these other disciplines and pose them for visualization. For instance, much prior work has revolved around the differences between novice and expert designers. Here we can ask questions like the following. How do novices and experts differ with respect to problem framing? Are experts capable of more flexible ways of recognizing and framing problems? Or how do novices and experts differ with respect to chunking while generating ideas? And do experts engage in more sophisticated chunking strategies that allow for more nuanced application of visualization principles? Another line of research can select individual concepts or topics to study. For instance, with respect to a topic like creativity, the ways in which cognitive strategies are used during ideation and how designers may get fixated on certain things could be investigated. So, given an example of a well-known visualization for a particular kind of data and context, we could ask whether designers become fixated on a particular kind of solution and being unable to see viable alternatives. And we could also ask what kind of supports we could give designers to help them mitigate that kind of fixation. Another line of research may characterize the similarities and differences among visualization and other design fields with respect to designers' cognition. For instance, do visualization designers rely on abductive reasoning in similar ways to instructional designers or others? Is mental simulation different for visualization designers and user experience designers? Or what kind of strategies, metacognitive strategies, do visualization designers rely on that might be similar or different to software engineers? With respect to research methods, previous research has heavily relied on protocol studies. This method involves asking designers to think aloud while doing design activity. Similar to other kinds of VIS research, designers can be studied both in controlled settings, such as a lab or a workshop, and in less controlled settings, such as their everyday design contexts. Studies in controlled settings are beneficial as they allow common tasks to be given to participants and variables like time and resources to be controlled. However, they differ from realistic practitioner contexts in multiple ways, and it's uncertain how ecologically valid these studies tend to be. Future research could involve a mixture of these methods, combining controlled and in the wild settings. Here I've presented a case for studying visualization designers' cognition. Perhaps the most obvious implication for this research is in the education and training of future visualization designers. However, there are also implications for research and design practice in surfacing research questions and in guiding future research studies at the intersection of visualization and psychology. Thanks for listening.
Thank you, Paul. Very interesting talk, and also thank you for introducing actually a new new topic and a new perspective on visualization. So there has been some conversation going on Discord, which actually has raised an interesting question. So oftentimes, the designer's approach is very much constrained by the type of tools that they have available. And oftentimes these tools have default settings, which may not be ideal to match the most effective visualization to the task that the designer is asked to perform. At the same time, this can also constrain the creativity and decision making, and at the same time also influence the reasoning process. Do you think your proposal could actually benefit the challenges imposed by how designers have to approach a problem, and what is your take on this?
Yeah, sure, thanks. I was just in the middle of typing a response on Discord, but I'll say it here. I think this issue of tools is important. And I think there's another take here, though, that there's another question here in Discord about having to design under time pressure. So if we bring those together, if we look at studies in decision making among experts who have to operate under time pressure and uncertainty, what we find is that experience and skill are critical, and people tend to rely on intuition, which is really about sort of recognizing patterns in prior experience. And so I think assuming that the tool, offloading too much of the responsibility onto the tool is potentially a problematic idea. So on one hand, the tools constrain what can be done, but I think on the other hand, the point that I'm trying to emphasize here is that focusing on the designers and how they think, in doing so, we need to understand how they make decisions and how they operate under time pressure, even with tools. And so I think we can't neglect the training and experience piece of that and simply offload that responsibility onto the tools. I don't know if that answers the different questions that were going on there, but I think it's really about the training and experience, relying on patterns of experience for quick decision making, and then doing whatever can be done with the constraints of the tools that are at hand.
Perfect. Thank you very much, Paul. Unfortunately, we are pressured for time as well, so I would move straight away into the panel session. So all three speakers, if you can be available, and if there are any interesting, any important questions you would like us to ask to our speakers, please publish them either on the Discord channel or on the YouTube channel, and we will ask the question as soon as they pop up. So one question I have, so we can just start the ball rolling, is all the three of you suggested new spaces in your talks and in your papers. And I was wondering if you see any overlap across your three different proposals or milestones that can be common to progress the field of visualization psychology, and that could benefit all the three strands that you have presented today.
I can start, I guess. So I think one, with Amy's presentation on external representation, there's been a lot of work in design theory and methodology on how designers use external representations as forms of thinking. Of course, we're all familiar with sketching and prototyping and so on. So I think there's some intersection there, and that we could leverage. I don't know if Amy has thoughts on that.
So can I Yeah, okay. So I think it's so each of us are like saying we should have a visualization psychology field, but approaching it from a slightly different angles in 2 different ways. And I think it's an interesting approach. And I think what we should do after this in the conference, we should actually see whether what kind of overlapping we could have and actually can actually work together and actually build on top of it, so we could actually see whether we have actually I'm using the word synergy to actually find if we could actually have a collaboration that we could actually work on it. And I think Amy just says on the chat the fire alarm is going off in her building, so she can't answer the question. So yeah.
Bad timing, unfortunately. So we have one question for the panel, which is, what would be the implications of understanding the metacognitive process of professional designers for everyday design process by average people at home? Is there any application first study?
The implications for understanding the metacognitive processes of professional designers. So I think the most obvious, and this is what I was trying to say at the end of my talk, there are others, but I think the most obvious is in the context of education, in training designers, and that can be either formally or informally. But I think, you know, there are a number of concepts that design theorists have come up with in this space, one of which is how designers make judgments. I'm giving a talk on this on Thursday morning, and how designers make instrumental judgments, for instance, which refers to how they choose the kinds of methods that they're going to use that are appropriate for the given design situation. That requires some kind of metacognitive awareness to know your own knowledge and your own thought process and be able to leverage that in the given situation and the contextual factors that are at play. So again, I don't know if that's answering the application part of it, but I think that's a practical implication for knowing something about metacognition of designers in their process.
So it's interesting because yesterday we organized a workshop on sort of like visualization guidelines, and I think one of the panelists was talking about guidelines and theories and how we can actually apply it to sort of like visualization and how we could actually analyze it. So it's sort of like for everyday design, it's sort of like for average people, it's actually quite hard to actually understanding sort of like to teach the visualization skills to teach how to actually read visualization. It will be quite hard to actually understand it. And I'm not sure if there's any application first study that actually has been done on it. I could be wrong.
Thank you. So actually we have one more question, which is, what do you all see as the core epistemological foundations of visualization psychology? Tough one.
That's a good question. So I'm the weird one coming at it from the designer side of things, so I can sort of talk about it from there. I think there's a really important, you know, and I mentioned this in my paper, and this is something that Donald Schoen pointed out in his famous work about practice having its own form of epistemology, and how there's been a really heavy influence from positivist epistemology in design, and especially from sort of engineering and psychology perspectives. And I think what we need to do is ask what the epistemology of design practice is. And I don't know exactly what the specific label is, but I think we can say that it's not quite fully a positivist stance. And there's certainly more interpretivism going on, and there's a lot of knowledge construction that's taking place in a contextual and pluralistic way. And so I think from the design cognition side of things, I think we need to at least somewhat move away from a positivist stance to one that's more interpretivist and acknowledges the social and contextual construction of knowledge in design practice.
Thank you, Paul. Alfie?
So it's interesting. So I don't really, well, I'm saying this on YouTube and live to quite a lot of people. So I guess it's sort of like, what do we actually need for visualization psychology? It really depends on the context and the problem that we're trying to solve. And different people bring different set of skills. For example, in Kuno's presentation, that if you're a VIS researcher or VIS student, you're studying sort of different things. And then if you're a psychology student, you're studying different things. And if you're a computer science students, there are different types of focus that you're looking at. So I guess it's a lot of different things that you need to actually look at. So it depends on the context and the problem. And I think it's sort of like, it needs to be done in sort of like a combined way of doing things, of a collaboration between sort of psychology and visualization.
We also have a contribution from Amy, and she's saying that, for me, all of these phenomena can be reduced to a triadic semiotic relation. I think building our empirical work on an understanding of the relation between a thing in the world, the thing we construct to refer to it, and then the meaning that is constructed is key. Fantastic. So thank you to all of you. It was a really great session, and thank you very much for answering your questions so promptly and so deeply as well. So I think we can move on now to the closing remarks, and we are actually perfectly on time. Thank you once again.
Bye.
Bye.